All right, as you see, we're doing special right triangles. Should have had this ready before I started, but let's grab a triangle, grab a right triangle. I guess this one could be a special. It's not like we're leaving out all the other triangles. Don't feel bad for the other triangles. But these are kind of special. And we're going to have to do a little bit of memorization with some of this stuff, okay? So let's see. Let's make one that looks like that. It may not be exact, but it's close enough. That looks all right. So what I did is I drew a triangle. What do you think might be true about these sides right here of this triangle? I just eyeballed it, so I can't say it's exactly. But what does this side and this side kind of look like? They might be what to each other? They might be. They're pretty close. Somebody just take a wild guess. They might be what? What if I did that? What would that tell you? Yeah, it looks like they're kind of equal to each other, doesn't it? Does it to you? Yeah, it does to me. That one and that one look pretty close to about the same length. Would you agree? All right. I don't know if you remember from geometry. Everybody's up here? Okay. So I don't know if you remember from geometry, but this has a special name. Do you remember the name of this triangle when you have two sides equal to each other? It could be any triangle. It doesn't have to be a right triangle. It could be any triangle that has two sides that are equal to each other. Anybody remember? Some crazy name starts with an I. Isosceles, very good. This is called an isosceles triangle. I'm not going to test you on that, but I just wanted to remind you of that. We also had a thing in geometry. I don't know if you remember this. If you have two sides equal to each other, what do you think is possibly true about these two angles right here? Kind of gave it away. What do you think? What's true about these two angles if these two sides are equal to each other? Just take a wild guess. They're the same. They're equal to each other. Okay? You remember that at all? Any of this coming back from geometry? When did you have geometry? 2 years ago? Okay. So yeah, it's been a while, but that was a pretty important thing in geometry. So now you're remembering it. Now, here's something that we've done this year that you should be able to tell me what the degree angle of each of these two angles are. If I tell you these angles are equal to each other, tell me how many degrees is this angle and how many degrees is this angle without me giving you any more information. That's all the information I've given you. You should be able to tell me how many degrees this one and this one is. 45. How do you know that? Because you know the other two angles have to add up to 90 because you already got a 90 here. We've done that this year, right? In this class, in this chapter. Okay, we said the other two angles have to add up to 90. Well, if they're both exactly the same, what do you do with that 90? Just split it in half, right? So it's half of 90. It's 45. I'll tell you what, let's get rid of these little things right here. Get rid of that. Get rid of that. All right, and let's put the numbers in. So this is 45 degrees, and this is 45 degrees. Now, what I'm going to do, I kind of hate doing. Maybe eventually I will get to this, but give you an explanation of why these two sides are what they are, okay? If I had a whole class period, and I kind of do, but I don't, because I got to go over that homework. But I'm just going to show you. To tell you the truth, at this point in the school year, you probably don't care why this and this are equal, but eventually I will show you, all right? So, you know, if you're like, Mr. Hamrick, why in the world is that side equal to this and this side equal to that? Well, I will show you eventually, just not right now. Everybody okay with that? If you really push me and you're like, Mr. Hamrick, I got to know why this side is this, okay? I could tell you, but not right now. All right, so I'm going to give you a number. It's a weird number, but it's a number that you need to have memorized. Everybody got it? Okay, so you need to memorize this number. Anybody taking notes? So this side right here, if you have, we call this a 45, 90 triangle. That's the symbol for triangle. Okay, we call it a 45, 90 triangle. Pretty obvious why we call it that, right? We didn't just make it up out of the blue. All right, you got a 45, and a 90, obviously. All right, so if you have that, the two sides, man, I'm blanking. This is a hypotenuse. This is a leg. That's what I'm trying to think of. Okay, this is a leg, and this is a leg. They're equal to each other. They're both going to be the same exact thing. So this is going to be the square root of 2 over 2. If you really wanted to know how to do it, what you would do is this. This length is A, this length is A, and we'll call this C, okay, just because it's not A and B. Why did I call them both A? Because they're both equal to each other. Looks like I am explaining why you got this, okay, but you can do Pythagorean Theorem, A squared plus A squared equals C squared. You work it out, and you're going to find out that A is actually equal to the square root of 2 over 2, all right? Just for the sake of time, I'm not going to go through that, but at least I kind of gave you an idea why. And we could, I mean, it's really not that hard to do, but that's that. And what we're going to do on these, when we do this trig stuff, and again, there's a reason for this, and I think the next section, we're going to do this. We're going to do a thing that's called the unit circle. And what we do is we call this hypotenuse 1. All right? You'll see when we do the unit circle. I'm sorry to be so secretive about this, but it's just too much to get into right now. Okay, the next section we will get into it. But I'm going to call this hypotenuse 1. If this is 1, then this is the square root of 2 over 2, and this is the square root of 2 over 2. All right? That's what you're going to have to memorize. You're going to have to memorize that. Now, why did we do this? Because we're going to find, guess what we're going to do? In this whole section, what have we been working on? There's trig functions. What are your main 3 trig functions? The first 3 that we've talked about. What are they? Sine, cosine, and tangent, okay? So what we're going to do is we are going to figure out what the cosine, let's do sine first because we go SOHCAHTOA, don't we? So let's go sine, cosine, and tangent. Now this is not just of theta, this is of a particular angle. What is this particular angle right here? It's 45. So these are special right triangles because these are things that you should be able to memorize. If I ask you what the sine of 37.8 degrees is, you're not going to have that memorized. I don't think anybody's got that memorized. You would put it into a calculator, wouldn't you? Yeah. But if I asked you what the sine of 45 is, you should be able to tell me right off the top of your head. All right? And that's what you're going to have to memorize. Everybody understand this? Okay, so these are special triangles. We're going to do another triangle after this, but this is your first one. This is the easier one. Okay, put degrees equals. So the sine of 45. Now let's take a look at this, and we could figure out now what the sine of 45 degrees is. So you could either use this angle or you could use this angle. It doesn't matter. They're both 45. So what is the sine? What's my little device that I remember sine, cosine, tangent? What is it? SOHCAHTOA, right? So let's use the SOH, the sine of 45. It's opposite over hypotenuse, all right? So 45 right here, what's the opposite side of 45? This square root of 2 over 2. Agreed? So that's the square root of 2 over 2. That's the opposite over the hypotenuse. What's the hypotenuse on this triangle? It's 1. So that works out really nice and easy, doesn't it? So if I asked you what the sine of the square root of 2 over 2 is, you should be able to tell me it's the square root of 2 over 2. That should be memorized. Okay, you shouldn't have to put it into a calculator, right? I don't want you to know the decimal approximation of this. I want to know exactly. Okay, these are exact values right here. They're not approximations. See, that's not a squiggly equal sign. It's a regular equal sign. So it's exactly equal to the square root of 2 over 2. Let's pull up the calculator. Let's push this over here. I might have to move it. Let me see what it looks like on my... Let's move this over there like that. Okay, there we go. All right, let's put the sine of 45 and let's see what we get. So I'm going to put sine... Oops, I got to use the mouse pad. 40, I'm sorry. Let's do this. The sine of 45. You don't have to close the parentheses. I like to sometimes, but we'll just do that. So that's that number right there. Everybody see it? Oops, you know what? That's not right. Guess why? What did I forget to do? You got to remind me every time I use this thing because I can't save it. I always got to change it to what? Degrees. Sorry about that. When I used to teach math and I had this calculator on my computer, I could save it. But right here, watch. When I try to do it, see it says exit and save state. It's grayed out. Doesn't let me do it. But so anyway, it refers back to radians every single time. So let's try it again. So we're doing the sine of 45 45 equals, and there it is right there. That's the number it should be. All right, so that's the sine of 45. Well, what is the square root of 2 over 2? Like, I don't know that that's square root of 2 over 2, so let's put in the square root of 2 over 2. So, got to bear with me because, again, it's been a long time since I've used this calculator. Square root of 2, I don't know, I'm kind of OCD about that. I like to close that parentheses, and then divide that by 2, and then equals, look at that. Would you agree that the sine of 45 is the same thing as the square root of 2 over 2? Absolutely, okay? So I'm going to keep that calculator right there because we're going to come back to it. All right, what about the cosine of 45? Well, what's the cosine? Cosine is adjacent over hypotenuse. But guess what? The adjacent is the same exact thing as the opposite. So guess what the cosine of 45 is going to be? Yep, it's going to be the same thing, square root of 2 over 2. All right, I'm not going to do it now just for the sake of time, but if you wanted to put it in your calculator and see if the square root of 2 over 2 is the same thing as a cosine of 45, feel free, it is. Tangent of 45, what's the tangent? TOA, T-O-A, opposite over what? Adjacent. So what's the opposite of 45? Square root of 2 over 2, right? This side is opposite. Over the adjacent. What's adjacent? This side right here is adjacent. So what is that? Is this real hard math? It looks like it is, because you got all those square roots and fractions and all that, but it's really pretty simple, because you just have something over itself. What's anything over itself? It's 1. Let's put that in here. Let's see if the tangent of 45 actually is 1. Do you believe me? I don't know. I could be pulling your leg. Tangent of 45, there it is. It's exactly 1. It's not a decimal. It's exactly 1. All right? You should have these memorized. The sine of 45, cosine of 45, tangent of 45, memorize those. Square root of 2 over 2. Really, that's the only thing you really had to memorize, right, is square root of 2 over 2. We're going to say that so many times that that should just be locked in your brain after a while. Square root of 2 over 2, square root of 2 over 2. Keep telling yourself that. All right, that's your first special right triangle. We only have one more, so that shouldn't be so bad. So let's scooch this up. Scooch. Do I still have my triangle? Yep. And now I'm going to change the look of this triangle. I'm going to make it look kind of like that. Again, it may not be to scale. It may not be exactly what I want, but it's close enough. Okay, there we go. It's a right triangle, so I'll put a little box right there. Now what I'm going to do is I'm going to put some angles in here. I'm going to say that that's 30 degrees. So if that's 30 degrees, tell me really quick, what's this angle up here at the top? 60 degrees. So take a wild guess what name I give this triangle right here. It's not 45, 45. What is it? Well, it's not isosceles. We just did an isosceles. 30, 60, 90. That's right. This is 30, 60, 90 triangle. And you don't have to say 30, 60, 90 right triangle, do you? Because you already had the 90 in there. So it's just a 30, 60, 90 triangle. That's a weird looking triangle right there, but you get the idea. Now, again, let's go back to geometry. This is still our hypotenuse. And what do we always make our hypotenuse on these special triangles? 1. All right, I'll show you why later on. We do a thing called the unit circle. All right, and the unit is 1. This is the radius of the unit circle. We'll get to that. This side right here in geometry. Trying to think of how much. No, I'm just going to tell you. I'm not going to try to explain it. All right. This side right here, if this is 1, in geometry, we learn that this is the shorter side and this is the longer side. I don't know if you remember that from geometry. You had a short leg. I should say leg, not side. Okay. You had a short leg and a long leg, and you had a hypotenuse. And we said on a triangle like this that the short side is half of the hypotenuse. I don't know. Do you remember? Does that ring a bell at all to you? Yeah. So this is half of the hypotenuse. If the hypotenuse is 1, then the short side is 1/2. Now, the long side was the square root of 3 times the short side. I don't know if that rings a bell or not, but if it doesn't, that's fine. Okay, let's just use that geometry theorem or whatever it was, postulate or whatever it was, to figure it out. So the long side is the square root of 3 times the short side. Well, I know the short side's a half, so what is the square root of 3 times a half? It's the square root of 3 over 2. Wouldn't you agree? If I took the square root of 3 over 1 times 1 over 2, it's the square root of 3 over 2. All right. Again, memorize these. All right. Memorize that the short side is a half. Now, watch this. The short side, or the half, is across from the smallest angle. Do you see that? See, the 1/2 is smaller than 1, and it's also smaller than the square root of 3 over 2. Square root of 3 over 2 is like 0.86 or something. I forget what it is off the top of my head. I think it's 0.8 something. All right, so 1/2 is smaller than 0.8. Would you agree? So the short side is a half, and it's across from the 30-degree angle. That's really important. What I'm telling you right there, remember that. So the shorter leg is across from the 30. The longer leg is across from the what? The 60. The longest side of the whole entire triangle is always the hypotenuse, right? So this is definitely going to be the longest side. So this is 0.5, this is like 0.8 something, and this is 1. So this is across from the 90. The smallest side is across from the smallest angle. The longer leg is across from the bigger angle of the two. All right, that was a whole lesson in geometry, super quick. All right, but this is a little review. But what we're concerned about is what? It's the sine of all of these. So let's just do the 30 right now. We'll do the 60 in a minute. So let's do the cosine of 30, sine of 30 first, then the cosine of 30, and then we're going to do the tangent of 30. These are ones that you should have memorized. When I say memorize them, what I do, if somebody walked up to me, right, on the street and said, yo, what in the world is the sine of 30 degrees? I may not think of it right off the top of my head, okay, but I would be able to visualize this triangle. That's what I would do. If somebody came up to me and asked me the sine of 30, I would visualize this triangle and then look to see which one is opposite, which one's hypotenuse. So watch how easy it is to find the sine. We did this on the other triangle. It's the opposite over the hypotenuse. So it's 1/2 over what? 1. What's 1/2 over 1? It's just a half. So the sine of 30 is a half. You believe me? Is this on? Did it go away? There we go. Oh, there we go. Just went to sleep, I guess. So what am I doing? The sine of 30? So watch. The sine of 30 is right there. It's exactly a half, 0.5. No decimal approximation. Agreed? Yeah. Let's do the cosine of 30. So what's the cosine of 30? The cosine of 30 is adjacent over hypotenuse. Which one's adjacent? Square root of 3 over 2. Oops. So it's the square root of 3 over 2 over 1, which is what? Just the square root of 3 over 2. Again, that's something you should have memorized. So let's see if it is. So let's put in cosine of 30 first. See what we get. Yeah, I was right, 0.86. Isn't that what I said earlier? Yeah. Let's figure out what the square root of 3 over 2 is. So here's the square root of 3 divided by, let's close the parentheses. I feel more comfortable doing it that way. Divided by 2. And then let's see what we get. Ah, look at that. Exactly. Every single decimal is exactly the same as the cosine of 30. So would you agree that the cosine of 30 is the square root of 3 over 2? Sure you would. Okay, it's right there. What about the tangent of 30? Well, let's do the tangent. Here's the 30. What's the tangent? It's the opposite over what? Opposite over adjacent. So we might have to do a little bit of math here. So there's the opposite, and then this, I have to move it up just a tad so I can see it, over the square root of 3 over 2. So how do we work that out? Let's do this up here in this blank spot. So instead of divide, what do? We multiply by the what? Reciprocal. So it's going to be what? 2 over square root of 3? Yeah? The 2's cancel. I'm going to do this super quick. So I get 1 over the square root of 3. We don't memorize that because the square root of 3 is in the denominator. So how do we get rid of that? We've done that this year. We do this. That's the square root of 3 over what? 3. So there it is. The square root of 3 over 3. That's the tangent of 30. I'm running out of time. Would you believe me if I put it on the calculator? Sure you would. Okay, it's worked every other time. It should work this time, right? So you can put it in the calculator and see for yourself. All right. What I want to do now is I'm going to go through this a lot faster. What I want to do is now find the sine, cosine, and tangent of 60 degrees. Okay? So let's do that with this triangle. Instead of using a calculator, I'm going to use this triangle and all the stuff that I know about this triangle from geometry, and I'm going to figure out the sine, cosine, and tangent of these angles. These are special angles. We're not going to do this with every single angle, all right? There's no special thing to remember with a, what did I say, 37.8? Okay, you're not going to remember that. You only have a handful of these special angles that you're going to remember, but this is really important. So the sine is 60. So now we're going to come up here to this 60 degrees. So the sine of 60 is what? Opposite over hypotenuse. So it's the square root of 3 over 2 over 1, which is just what? Square root of 3 over 2. Let's do the cosine of 60. It's adjacent over hypotenuse. It's 1/2 over 1, which is what? 1/2. Do you see any kind of a pattern going on here? I do. What about the tangent of 60? This might blow the pattern a little bit, but it really doesn't. So watch. It's opposite over adjacent. So it's opposite over adjacent. So it's the square root of 3 over 2 divided by 1/2, or times what? Just 2. The 2's cancel. So what's the tangent of 60? It's just the square root of 3. Look at that. Do you see this? Do you see the relationship here? Look, the sine of 30 is the same exact number as what? You guys are killing me. I'm pointing right at it. The cosine of 60. Do you see it? Yeah? Look, the sine of 30 is 1/2. What's the same thing as the sine of 30? It's the cosine of 60. Thanks for playing along. Look at the cosine of 30. The cosine of 30 is the square root of 3 over 2. What's the sine of 60? All right? Do you see what it's doing? All right? If I take the cosine of one angle, guess what? The sine of its complement. Do you remember complement from geometry? It's the difference of 90 degrees. All right? So 30 and 60 are complements of each other, right? So the sine of one angle is the same as the cosine of its complement. Hear what I just said? That was pretty important. All right, so that's something that's nice to remember. All right, and these are kind of inverses of each other, right? If I put 1 over the square root of 3, it's the same thing as square root of 3 over 3. All right, so that's kind of interesting to see as well. All right, that is your special right triangles. So I'm going to give you a worksheet, and I'm going to go over that worksheet that was due today. We still have some time. Yes, sir.
So for special triangle, the hypotenuse is always
on these, yes. And I'll show you why in the next lesson that we do in 13.2. I'll show you why it's 1. But
and then the short leg is always going to be 1/2 of it.
On a 30, 60, 90, the short leg is always half of this. So what if that hypotenuse was 8? What would the short leg be? It'd be 4, right? And what would the long leg be? It would be the square root of 3 times 4, or 4 square root of 3. But in this case, we made it real easy. We just made it 1. Okay? You follow me on that? But the sine, cosine, and tangent would be exactly the same no matter how big the triangle is. This is a little tiny, small 30, 60, 90. The sine, cosine, and tangent is exactly the same as if it was like a big, gigantic 30, 60, 90 triangle. All right? So those are things that you should memorize. All right? Sine 45, cosine, tangent of 45. Have those memorized. Or at least be able to picture this in your head, right? And maybe figure it out. Or jot it down on a piece of paper. You should be able to figure it out. But you should be able to figure these out. If I ask you on a quiz or a test, what's the cosine of, let's say this. If I ask you on a quiz or a test what the sine of 60 is, if you put 0.866 in all those decimal places, I'm marking it wrong. Because I'm going to ask you for the exact value. 0.866 whatever is not an exact value. All right? The square root of 3 over 2 is an exact value. You with me?
If we hit fraction and a calculator, what's greater?
I may possibly, if I give you something where I just ask you these, I may possibly not let you use a calculator. Because I want you to be able to do this without a calculator. Okay? All right. I saw a thing on Facebook, dumb old Facebook. These people always make fun of math, makes me mad. So they put the shoot, what was it called? The quadratic formula on there. And it's like something like raise of hands, how many people have ever used this in their life or something like that. Then one teacher put it on there. Yeah, I use it all the time. I teach it to my classes every year. So that's about the only reason. Anyway, so I'm going to give you a worksheet, and that worksheet is named special right triangles. How about that? Okay, I'll give you that to you in a second. We will go over the homework here in a minute. Okay, special right triangles. Okay, so that's going to be your homework right there. I will give it to you. If for some reason you're listening to this online and you weren't here, you can go to Teams, go to Files. You'll see a worksheet. It's 2 pages because I'm going to give you a front and a back. It's 2 pages and it says special right triangles. All right, enough of that.